Welcome. In this video, we'll learn about object tracking using background subtraction. Background subtraction is a technique that models the background in a given video and then uses that model to detect moving objects. This technique is used a lot in video compression as well as video surveillance. It performs really well where we have to detect moving objects within a static scene. The algorithm basically works by detecting the background, building a model for it, and then subtracting it from the current frame to obtain the foreground. This foreground corresponds to moving objects. Enough of definition. Now let's see in practical what I really want to say. So this is a script that is background subtraction.py. Now let's open it. Now let's move to the output and run the script. You can see this one is input and this one is output. If I don't move, the output screen will go black and it will ignore me as a background. If I move a little, it will identify me and show me. In background, you can see one person is moving. It is ignoring me and identifying me. So when I move, it identifies me, else it ignores me. So in this way, it subtracts the background and only show the moving object. Once you stop moving, it will start fading because you are now the part of the background. So this is what I was saying, that is object tracking using background subtraction. It will just subtract the background. Now let's see the code behind it. So the first one is import CV2, which you know it, and next one is import numpy as np, which you also know it, and the next one is define a function to get current frame from the webcam, that is def get frame, and then read the current frame from the video capture object, that is frame is equal to cap.read, and then resize the image and return, that is frame equals to cv2.resize. Now let's define the main function here, that is if name equals to main. Define the video capture object. If secondary camera, then replace 0 with 1, that is cap.cv2 video capture 0. Here I'm using primary camera, so 0. Now define the background subtractor object. Now bg underscore subtractor equals to cv2 dot create background subtractor emoj 2. Now define the number of previous frames to use to learn. This factor controls the learning rate of algorithm. I'm writing here history is equal to 100, so I'm just considering 100 frames. If you don't know what is a frame, usually a video has 24 to 60 frames. A normal video is of 24 frames. Some capture it at 30 frames. Most of the video games are at 60 FPS. So here I'm just counting 100 previous frames. The learning rate refers to the rate at which your model will learn about the background. Now define the learning rate. Now learning rate equals to 1 divided by history. Now keep reading the frame rates from the webcam until the user hits the escape button. So we'll create a loop, that is while true, grab the current frame, that is frame is equal to get frame cap 0.5. Mask bg underscore subtractor dot apply frame learning rate equals to learning rate. It is computing the mask. Now convert the grayscale image to RGB color image. So mask equals to cv2.cvt color. Now here gray to bgr. Now display the input and output images. You saw there were two windows, one which was input and another was output. So here input and output. The output is masked and framed. Now check if the user pressed the escape button. If so, exit the loop. So c equals to cv2.wait key 10. If c equals to 27, then break. Now release the video capture object. So cap.release. Once you exit the loop, make sure you release the video capture object and close all the windows properly so CV2 destroy all windows. So this is good. Let's see the output again. Run the script. If you run the code, you will see a window displaying the live output. If you move around, you will partially see yourself as shown here. Once you stop moving around, it will start fading because you are now a part of the background. The algorithm will consider you as a part of background and start updating the model accordingly. If another person move around, then it will detect, and as soon as it stops, and it will stop detecting as you remain still. It will continue to fade as shown here. The process of fading indicates that the current scene is becoming the part of the background model. So coming back to the code, what we did here more is we just used create background subtractor and we wrote a little code of just counting the previous 100 frames, and the few line of code got this output. We are just using already written library. So that's it in this video. There is no such more thing to explain in this video. If you didn't got, please do watch this video again. So that's it in this video on object tracking using background subtraction. Thank you for watching this video.